Okay, so this says find the center and the radius of the circle x squared plus y squared plus 2x minus 3y plus 11 fourths is equal to 0. So this equation here, you might not necessarily be able to recognize that it's a circle. I'm kind of seeing here this, the squared on the x term and the squared on the y term sort of reminds me that it might be a circle, but this would definitely look sort of a lot clearer if we could sort of think about rewriting this equation in the general form for circles. X minus h, or x coordinate, squared minus y minus k squared is equal to r squared. That's sort of our standard equation for a circle. Okay. And so what we're going to do, this whole question is going to be about sort of trying to rewrite this equation that they've given us into this form. Okay, and if we have it in this form, remember from before that we can just pick off the center as being hk, so whatever numbers are sort of there on the inside of those brackets, and the radius is just going to be whatever number is there sitting on the right hand side if we could rewrite it as a square. Okay, so this whole idea of this question is going to be to try to rewrite this equation. So our first step here is I'm going to try to group together my like terms. So this x squared here sort of has to do with x, and this 2x here has to do with x. So I'm just going to write those together. So they're sort of, together in the same place. So I'm just changing around the order, okay? And the y squared here and the minus 3y, those are both terms that sort of have to do with y. So I'm going to write them together. Okay. And the 11 fourths, it's a constant, so I'm just going to move it to the other side. We can sort of think of subtracting 11 fourths from both sides. So all I've done there is sort of just rearrange the order of the terms so that the x terms are sort of grouped together and the y terms are sort of grouped together. Oops. Okay, so from there, now we're going to go through and we're going to complete the square. So this is one of those tricky things that we may have talked about back when we talked about parabolas a little bit. Okay, so what we're going to go through and do is we're going to work out the magic number that we're going to need for our x terms. Okay, so in order to work out our magic number, we're going to look at this number in front of the x term. Okay, and our magic number, we're going to take that number there, that 2, we're going to divide it by 2 and square it. Okay, so we've got 1 squared, which is just 1. So what we're going to do is you can think about sort of adding 1 to the left-hand side of the equation. And in order so that we haven't changed the original equation, we're going to add 1 to that right-hand side as well. Okay, so we haven't changed the original equation there. We're just strategically adding a 1 to both sides. Okay, and then I'm going to do the same thing here for my y terms. So I've got my y squared minus 3y. I'm going to look at the constant that's sitting there in front of the y. And in order to work out my magic number for my y's, I'm going to take that number, minus 3, divided by 2, and then square it. Okay, now this one's going to be a little bit uglier to work with. So if I have minus 3 over 2 squared, I can think of just doing minus 3 squared over 2 squared, which gives me 9 over 4. So that's my magic number that I have to add to my left-hand side of the equation and also to the right-hand side of the equation. Okay, so again, I haven't changed the equation there. I'm just strategically writing it a little bit differently so that it will eventually look like this standard equation for the circle. Okay, so from there, now I'm going to look at sort of all these things here in red, the x squared plus 2x plus 1, and that there is going to factor as a perfect square. So what I mean is that I have to be able to think of two numbers that multiply to give 1 and add to give 2. Okay? And those numbers, if we really think about it, would be 1 and 1. Okay? Which means that I can write this as x plus 1 times x plus 1, which I could just write as x plus 1 squared. Okay. Another way that sometimes students like to think about it is they just sort of think about this number inside the square, right? Whatever that b number, that 2 divided by 2, which in this case is 1, that's the number that's always going to end up here in that spot. Okay. All right, now we go over to our y terms. Okay, so again, those are going to have to factor as a perfect square, that y squared minus 3y plus 9 over 4. So we're looking for two numbers that multiply to 9 over 4, and they're going to add to minus 3 over 2, which is going to be maybe a little bit trickier to sort of think about in your head. So let's go back to that other rule that says that we're just going to take that minus 3 divided by 2. We're going to look at that thing right there, that thing inside the square. That's what it's going to factor as a perfect square. So we've got y minus 3 over 2 squared. Okay, so if I think about adding minus 3 over 2 gives me minus 3, and minus 3 over 2 squared does give me the 9 over 4. So I'm just taking those and rewriting those as perfect squares. And then from there, I'm just going to want to kind of group together all of these numbers on this right-hand side. In order to add them together, we're probably going to want to write them all as over 4. So let me just change this one. 1 is the same thing as 4 over 4. And that's going to allow me to sort of add these together. If I've got 11 over 4 plus 4 over 4 plus 9 over 4, that gives me 2 over 4. So I could write 2 over 4 here. But let's simplify that. Divide the top and the bottom by 2. That just gives me 1 over 2. Okay, so this new equation that we've got here seems to be a lot more sort of in the form of that standard equation that I talked about over here, right? Okay, so I might just want to rewrite it a little bit more so that I can pick off that h and that k and that r really easily. So instead of x plus 1, I could rewrite this as x minus minus 1. Okay. And then we can really clearly see that our h here, that's minus 1. Okay. Now this one's already sort of in that nice form, y minus 3 over 2 squared. So my k here is 3 over 2, positive 3 over 2. Now normally in our standard equation, let's just go back up here for a second. Normally in our standard equation, right, see there, that's r squared. So it'd be really nice if we could write that right-hand side as a square. So what I'm going to do is I'm going to take the square root of 1 over 2 squared. And if you can normally think of that square root and that square canceling to give the 1 over 2. Normally we'd sort of simplify it in that direction. But I'm rewriting it this way because then here I can see clearly that my r here, oops, I think I was doing lines here. The r is the square root of 1 over 2. Okay, so if they ask us, now that we've got it in that center, remember this question was asking us what the center and what the radius were, right? Okay, and so the center is negative 1, 3 over 2, and the radius is the square root of 1 over 2, which is not pretty. Some people might rewrite that as 1 over root 2. Some teachers might rationalize that, which is not really that important, but they'll essentially take this 1 over root 2 and multiply the top and the bottom by root 2 so that we get root 2 over, and then square root of 2 times square root of 2 gives me 2. So any of those three numbers there I think are okay if you leave those as your answer. But that's generally how we're going to go through and work with an equation that looks like this, is we're going to complete the square and try to get it rewritten in this standard form so we can pick off the center and the radius.